Here we go.
Beautiful.
That working?
Yes.
Great. And just a little bit about me. I'm a senior systems engineer here at Seven Signal. I've been here for 7 years. I actually checked my employment records last night because I was wondering if we had ticked over to 8 years yet, and I still got a few weeks for that, but getting close. And I have been designing, installing, troubleshooting, using wireless LANs for many years. In fact, since before Wi-Fi. So I've seen it all. As Heather said, we're releasing a refresh of the antenna selection and positioning guide. We got some people that are fluent in English to rework it a little bit and maybe make it a little bit more readable. So as Heather said, we'll send you a link for it. She'll put it in the chat, and
this is going to be a fun game, guys. So Mike is on. Should we even try to guess how old this computer is? It's on Windows 7, right?
Unfortunately so. Yeah.
Yep.
Heather?
There you are. We were just complimenting your intensely updated system.
My intensely updated system.
Yes.
Okay.
We lost you for a second, but it appears that you are back.
Oh, good. I hope that doesn't happen too much. I've been having some internet connectivity problems for the last couple of weeks. I'm pretty sure it's a wired problem. But as we were saying, it is a antenna selection and positioning guide. It's not deeply technical, but we try to talk a little bit about antennas and how you're going to use them and how you're going to select them. The guide starts out with, let me see if I can clear this off my screen. The guide starts out with defining a few terms and that are important to antennas, and not just defining them, but discussing them a little bit. And, I just pulled out a couple of quotes from these, and that's going to be what we see on all the slides. And the one for this one is talking about decibels. It's something that we talk about a lot in RF. And, the quote, consider that earthquakes or sound can be imperceptible or ear-splittingly loud. And, we need a way to represent that. And there are a lot of natural phenomena that are in that sort of scale. And I pulled a little bit of trivia that I thought was kind of interesting on decibels. I looked up Voyager 1, the space probe that's out on the edge of the solar system, and found out that its transmitter is about 23 watts or 44 dBm, but the receive power when it gets to Earth is this tiny value, 9 times 10 to the negative 20th watts. And that actually comes out to about negative 160 dBm. And that was in 2017. I couldn't find a more recent figure from that, but I'm sure it's farther away and a little weaker now. And as a final sort of a contrast, picking a radio station in Jimstown there, WLW-AM in Cincinnati. It's a 50,000 watt clear channel AM radio station. And I plugged 50,000 watts into the dBm calculator and came up with about 77 dBm. So, it's kind of cool with the logarithmic scale. We can represent this massive range of power differences, 10 to the negative 20 up to 50,000. with only about a range of 250 dB units. So it gives us the ability to really represent an extraordinarily wide range of power levels very easily and with units that make a lot of sense. And that's what the dBs are about. Something else that just coincidentally, when I was looking up things for this, that's, something like 250 dB between Voyager 1 receive power and WLW. And I found out that an atomic bomb going off in the room with you would be about 250 dB sound level. So I thought that was kind of an interesting thing that you can represent sort of all of the power levels that RF engineer might be looking at in 250 dB, and from barely perceptible sound to one of the loudest sounds in about the same amount. Pretty cool, huh, Jim?
Yeah, and a little trivia about that trivia. WLW used to broadcast at 500,000 watts. And it's a clear channel station. So you used to be able to, at night, when the propagation opened up, you could get 700 WLW all across the country.
Yeah, those AM big AM clear channel stations are amazing. Back in sort of the early days of rock and roll, you had the giant Mexican radio stations that were running hundreds of thousands of watts that at night you could pick up all over the US as well. But yeah, that's a lot of juice. Slide. Our next major topic in the antenna guide is about antennas and selecting them, and a little bit on sort of the big classifications of antennas, omnidirectional, directional, and point to point, or sometimes I'll call those highly directional antennas. And how you use each one and where they work. And we've talked about antennas a lot. The internal antennas and access points, which are usually quite small and have what I think the manufacturers call a semi-hemispherical pattern, or what I tend to call the blob pattern, because it doesn't have a lot of structure to it. It just sort of covers the area under and around the access point, and how those are great in indoor carpeted spaces and so forth. And we talk about when you can use big high gain antennas, and when we can use some directionals, and what point to points are good for, or what highly directional antennas are good for. So interesting material, and I know that we've covered it in a lot of our antenna webinars, and we try to distill some of that into the new document. What do you think, Jim?
It's interesting to see the history of the document too, because the priorities when it was first written were how to get a huge coverage cell with one AP. In today's networks, you rarely do that, because you need more capacity by deploying more APs with smaller coverage cells, so they're servicing fewer clients per AP. So it's interesting to see that document evolve and take on that new perspective on density.
Yeah, and it's been really different to live through it as well. I mean, I can remember when we were installing a lot of times frequency hoppers in warehouses back pre-Wi-Fi and sort of the first generation of Wi-Fi. The user density was tiny. You would have a 500,000 or 1,000,000 square foot warehouse, and it would have a few hundred clients in it at the most. and they were just scanning barcodes. So there was no capacity requirement. It was really all about coverage. And yeah, we would hang, typically 8 and 9 dB omnis, and we were covering 30, 40,000 square feet in a cell easily. So yeah, that's different than sort of the modern, particularly the carpeted space applications. Let's see, anything else to say on the antennas? On the point-to-points, we used to use Yagis a lot. And I don't see them much anymore. And I think that it's because the manufacturing cost is so much higher than a patch or a panel type antenna, and the performance is similar. I don't know.
Mhm.
I don't do a lot of installs anymore. So maybe if some people on the chat, let us know if you're using Yagis very much anymore. But I think that they've largely been replaced. What have you seen, Jim?
I rarely see Yagis used for Wi-Fi. It's what another reason might be they're so directional that aligning them is pretty difficult. You might need some specialized tools that installers may not have to actually make them work. So
Yeah, that may be part of the reason too, just that other antennas are easier to use.
Bruce in the
Um,
chat says Yagis don't hold up to hailstorms. I think he may have had a rough day and some bad weather with some Yagis. Lesson learned from
yeah,
Nebraska. Oh yeah, they got real hail out there for sure.
I remember back when I worked for a wireless services company, and we guaranteed all of our installs, and a tornado came and ripped the whole roof off of a building, and they wanted us to cover replacing their antenna under warranty. So yeah, that didn't happen.
And a good point from Stephen in the chat about Yagis usually being single lead, so only going to support a single spatial stream. So
Yeah, that's true. I guess you could build a dual pole Yagi. I don't know.
not sure.
Yeah. Anyway, moving on. Our next section is other considerations, really. We talk about going too far with high gain antennas, and we talked about that a lot on our omnidirectional antenna webinar, where when you get these really high gain omnis, they have a very flat pattern, not a lot of spread in the vertical direction. So if you mount them way up high, sometimes your users are all under the coverage pattern of the antenna. So we talk a little bit about that. In this section, we talk about being sort of aware of the dual band, single band antennas, 5 gig versus 2.4 versus a both. And I guess soon to be coming, we'll have maybe tri-band antennas that cover 6 gig. Actually, I've seen a few, so yeah, they're out there. And we also talk about some cable length and connectors. And cables are I kind of hate them, because what they do is they turn that hard-won RF energy, whether it's on the receive side or the transmit side, into heat. And good cables are wildly expensive. They really are. And actually, that reminds me of something on cables. If you find an extraordinarily good deal on a cable that should be expensive, it may be straight up counterfeit. I've had some problems in the past where cables that were actually marked times microwave, when you cut them up, they were clearly not times microwave cables. They were absolutely counterfeit. So that does happen. So too good a deal is probably too good of a deal. And then, I pulled a quote, and there's definitely a tension on this antenna gain thing, where we pointed out that if you replace an AP with that 3 dB approximately internal antenna with a big stick 9 dB, you're going to double the cell radius. That's quadrupling the area covered per AP. And of course, a quarter of as many APs. But as Jim pointed out, that is also 4 times the number of users on the same AP and a quarter of the performance. So it's important to really understand the user density and the performance requirements of where you're putting it. An antenna is a whole lot cheaper than an access point. And if you've got big open areas with not a lot of users, I don't see really a problem with running a lot more gain and getting a lot more coverage on an access point. But obviously, doubling the coverage or quadrupling the coverage doesn't increase the total amount of performance in that cell. What do you think, Jim, about that capacity coverage tension there?
Yeah, we touched on it earlier, but most networks today are designed with capacity being a goal. And it's pretty rare to only need to think about coverage anymore. There's also a really good lesson in this section on antenna reciprocity, which I think is unintuitive for a lot of people, but putting a higher gain antenna on an AP, yeah, it increases the reach of its transmissions, but it also increases the gain on the receive side too. So it has an equal effect on transmit and receive, unlike turning up the transmit power of an AP, which only affects the transmit distance. So important point from that section.
Yeah, that's kind of the first quote that I pulled out there. And you're right, a lot of people really only think of the antenna on the transmit side, but whatever it does for transmit, it does for receive. And usually that's a good thing. You're increasing the received signal strength of your clients. So they're going to be able to achieve better data rates on the uplink side, and all is good. It can come back to bite you, though, and that it hears noise better as well. So it may actually cause you to pick up a distant noise. I can remember putting a big stick Omni 9 or 12 or 15 dB up on a water tower, and this was long before everybody had an access point in their house, and I still picked up hundreds of access points up there. So not always a good thing. And really with directional antennas, if you know where your noise sources are, you can point a null in the antenna at those noise sources and null out that noise. Let's see. Our biggest section here is antenna placement best practices. I don't think that's a surprise. There's a lot to talk about there. And like the quote that I pulled from the section at the bottom, you always make trade-offs. Some placements are going to be good for some things. You're not always going to be able to put access points where you need to put them or want to put them. Maybe you can't physically mount them there, or can't get cabling there, or something. So access point placement is always going to be a compromise, and really that's one of the big advantages of doing a real site survey on site with a skilled technician. They're expensive, but you can resolve all those kind of local issues that may not be apparent from a plan of the building and a what am I trying to say here? One of those planning programs, the propagation programs. You know, you're not always going to know what's on site, what the furniture is, those sort of things. You know, we were, before the webinar started, we were kind of talking about one of those things that we mentioned, EM interference. And we specifically call out motors in the document. And Jim and I were talking, and I have never actually seen motors, even ones with variable frequency drives on them, cause interference at either 2.4 or 5 gig. And that's pretty industrial places. That'd be another one that I'd love to hear from, you know, whether other people have actually had problems with motors. Certainly, I've had problems with things like industrial heaters that are, you know, essentially giant microwave ovens that you might expect. I've had problems with computers that actually radiated RF pretty fiercely. Never in Wi-Fi, but one time in one of the cell bands, found a computer that really radiated quite fiercely in that band.
Good thing you found that before the FCC did.
Actually, I got a call from Verizon.
Yeah.
Yeah.
Interference in license bands is a different ball game.
Yeah. But you know, and it wasn't the radio that was doing it. It was a harmonic off of the clock on the motherboard, or off the processor on the motherboard, or something. It was coming off the motherboard on a PC, a single board PC. But it was fierce. And really, that's not the only time I've had interference from a computer. I had a problem with one long ago, and just to give you a sense for how long ago, it was a 486 DX50, which was the biggest, baddest server you could buy at the time. And it radiated really very fiercely on, you know, wideband noise.
Mm-hmm. Yeah, for a while, USB 3 devices were shown to pretty widely create interference in the 2.4 gigahertz band.
Yeah. So, you know, I guess the point there is, you know, you never really know where that interference is going to come from, but I've never seen it from motors. Like I said, even ones with variable frequency drives on them, which you might expect might cause some issues. I've just never seen it.
Yeah, and let us know in the chat if you have, or you have any other interesting sources of non-Wi-Fi interference you've discovered. One of the points that I like to raise in that section about compromises is you're not going to compromise if a customer or the building owner says, these are my requirements, and you just kind of accept them and have to do whatever, right? You have to, a compromise is the result of, you know, coming together with your set of requirements. What are the requirements for Wi-Fi to perform well? And okay, what are the requirements for the aesthetics of a environment or something like that? And let's compromise both there to come up with a good solution. So I like to tell people it's our jobs as the wireless engineers to fight for good Wi-Fi and say, okay, if you want me to put all the APs above the ceiling tiles with a big metal rack and ductwork around them, you're going to have bad Wi-Fi performance, and I can show it to you, right? So if that's a requirement, you have to accept this cost in terms of Wi-Fi performance, and is that acceptable for what you want to do with the network? So be an advocate for good Wi-Fi.
Yeah, absolutely. As Jim said, you have to maybe compromise a little bit in both directions sometimes. And we have near the end of the document, we have a little page on coverage versus capacity. I think probably we've beat that one pretty good. I'll just say you do need, as part of the site survey, as part of a design, you do need to understand what those user densities are, and whether you're going to need dense deployment of access points there, or whether it's, you know, a place that you really need coverage and it's not going to get much use, and you can try to stretch out the coverage on the access point a little bit. Well, yep, kind of overlapped on that one as well. I think make the point there that you know, site surveys are, yeah, they're really necessary before a deployment, so that you can work up a design. But even after it's deployed, having a site survey to come in and verify coverage, and doing that periodically to see what's changed in the environment, it's money well spent. And I know that all of our partners out there that do a lot of site surveys will agree with that. The final thing that ties into that, it's going to change, is some performance monitoring. You know, obviously we sell a product, but even if it's just, you know, monitoring the dashboard and monitoring the logs on whatever vendor system you have, do that, even if you don't have something, because networks change, networks break. You cannot just install them, turn them on, and walk away. What do you think, Jim?
Yeah, that's right. You know, it's not a one and done thing. It's you need to carefully design your Wi-Fi network at the outset, particularly if you're you know, spending the extra money it takes to use external antennas. You want to make sure they're deployed properly, and you're getting the most out of them. But you also want to have a plan to, you know, regularly check to make sure the network's meeting the requirements it had before. And often, you know, those do change over time. New clients show up, new applications show up.
Yeah.
The RF environment changes. And then there's, you know, the more frequent changes from RRM and, you know, other things, hotspots coming and going, and sources of non-Wi-Fi interference showing up as well. So you can never have too many eyes on it. Yeah, Wi-Fi interference too.
Neighbors change, you know. You get new neighbors, or your neighbors deploy a new system, and, you know, they leave it out of the box configuration running wide open on 80 megahertz channels, and, you know, kind of wipe you out. It definitely happens. But as I say, you know, you have to monitor, even if it's just using the vendor tools. You know, look at the logs, you know, check your access points, and make sure that they're actually, you know, have users and are passing traffic and that sort of thing.
Yeah.
And I think that,
monitor
yeah,
performance and have a plan to do, you know, routine site surveys as well, because you'll be surprised at how much things change. Even the environment changes. You know, the furniture in an area might change, or a wall might show up that wasn't there when you first did your design. So
things definitely
be surprised.
happen.
Yep.
And equipment fails. You know, we find all the time access points that are beaconing and appear happy, but, you know, they don't respond to probes or something like that. You know, access points do get hung, and they don't always complain back to the controller or the management system that there's a problem. So, you know, obviously something like 7Signal that constantly connects and tests them is the best way. But, you know, failing that, you got to monitor the system. And I think we'll go to any questions now, if there are any out there.
Yeah, thanks, Mike. And I think a lot of people are just hungry to get their hands on the new guide. I think Heather put that link in the chat earlier. Thanks, Heather. But that is live now if you want to read the whole guide. And not a lot of questions that we haven't already covered, but there was one comment here from Jeff. He says, walls randomly appear from nowhere in hospitals all the time. And I've had that experience. I actually had the experience where a wall appeared in a hospital, and there was an AP mounted on the ceiling where they wanted the wall. So they built the wall around the AP. They just left the AP there, cut out a little piece of drywall on both sides, and built a wall straight through the AP. And the only reason I mean, this is a long rant, I'll try and save it, but the only reason I found out is because they started having performance problems in this clinical wing of a hospital, believe it or not. Anyway, Jeff's right. You gotta go see with your own eyes what's going on there. So
I think we got one from Bruce in here, Jim, in the Q&A panel.
Yeah, question from Bruce. So he says, back in the days of diversity, the antennas needed to be set a specific distance apart and had to be parallel. Now that we have MIMO, what is your recommendation for how to position multiple adjustable dipole antennas? And that's a great question, Bruce, because that's definitely a topic that we discussed coming up with the new guide. In general, Mike, we still want them to be parallel, right?
We do. If it's an omnidirectional antenna, we want them aligned the same. Usually that's up and down. So, and up and down are equivalent. So you could have, some of them pointed up and some of them pointed down, but you do want them parallel to each other. And for directional antennas, you want them pointed at the same area. So if it's a couple of patches, or 4, I guess, in these days, you want them pointed in the same place. And of course, if you're using, sort of pre-built MIMO antennas, that's automatic. If you're rolling your own out of a bunch of single element antennas, you do need to keep them pointed in the same place. And sometimes we talk about whether or not you should flip, half of them and do horizontal and vertical. And I've given it some thought, and I think I'm about to come down on the side of giving them all the same polarization as well. But I'm a little less clear on that. What do you think, Jim, for directionals?
Yeah, I don't get very concerned about polarization anymore, particularly with indoor environments and the multipath we experience, and the fact that, this device is going to go like this and like this and like this. And, maybe the antenna is on the AP are aligned in a way that we like, but the clients are always going to be a big mess. So I think it's better to have the same sort of coverage from each of the antennas, so the our each on the transmit side for the AP, each antenna is used for a unique spatial stream. So if we're using multiple spatial streams to transmit to a client, we want them to be able to have close to the same coverage area.
Yeah, absolutely.
Chris Kelly makes a good point about, I think he's talking about polarization just being really important for outdoor point-to-point links, and that's absolutely true. You can really lose a link, lose a huge amount of SNR if you're cross-polarized with a point-to-point link. Good news is, of course, you have control over both sides of the link, so you can correct that and fix it.
Yeah, and that huge amount of margin and it depends on there's a specification on an antenna that isn't always published called cross pole rejection, which is, how insensitive an antenna is to out of polarization signals. And it, on a good antenna, it's going to be 20-25 dB, something like that. So that's about, 20 dB drop is a huge amount of signal drop from a cross polarized antenna. And I definitely had that experience on an outdoor setup one time where I had my antennas cross-poled and couldn't figure out the problem. And I couldn't figure out the problem because the polarization stickers on the antennas were wrong, which was a very frustrating week that I still remember vividly. But yeah, outdoors makes a huge difference because you're not getting those reflections. It is antenna to antenna and the polarization doesn't change for the outdoor links. But indoors, every time you get a bounce, the polarization is potentially going to be altered.
Yep. Maybe one last question here. This is from Pedro. And he says, for warehouse deployments, do you choose to install external dipole antennas or patch antennas for a ceiling installation? He's asking about. What do you think, Mike?
Either like a low gain omni, like a dipole, like you said, or I prefer, if it's real high ceiling stuff, if I can possibly avoid the ceilings, to avoid them. And a lot of times you can't, just because warehouses where you usually get the high ceilings are so vast these days that there just isn't a wall there. But if I have to go on the ceiling, I'm gonna stick to really low gain antennas so that I don't keep all the signal up in the ceiling, whether that's a dipole or an internal antenna, or even a hemispherical, really low gain patch pointing down if it's real high ceiling.
Yeah, dipole is going to be, it's going to cause some difficulties, right? Because if you're using RRM, it's probably going to bring the transmit power down way too low with the APs. And you're going to create a lot of CCI. Maybe it's okay if your requirements are low, but I think these days a patch facing downwards is preferable.
Yeah, real low gain patch usually, just enough so that you're not firing it sideways.
Yep.
But the thing with high ceilings is there is not a great solution. There really isn't, especially in really big warehouses. Maybe you can go on the support columns and keep the radios and the antennas closer to the users, but it's tough.
Maybe at the end of the aisle on the wall, you can use a directional antenna to just fire down the aisle. That's a common design too.
I mean, it used to be it used to be scan a barcode and go to a location, and it was maybe a few hundred bytes in a transaction. And now a lot of those warehousing applications are much more sophisticated. They're doing database calls directly from the end client. They're not just a terminal anymore. They're really full network connection with full network traffic. And those giant cells in warehouses just don't work anymore. Just like they don't in carpeted areas. It isn't as big a deal, but the density and the performance requirements have pretty much come for everybody at this point.
Mm-hmm. All right. Well, Heather, I think that about wraps it up.
Yeah. Awesome. Well, thank you so much, Mike, for your wonderful presentation, and Jim for your input and feedback along the way. And of course, thanks to all of you for joining us today. We will be back same time, same place. Invites will go out Friday, so keep an eye on your inbox. But otherwise, I hope you all have a great rest of your week and weekend, and we'll see you back next week. Thanks, everyone.
Bye, everybody.
Thanks.